All right. Well, welcome to our little software engineering presentation today. Sorry, the microphone is a bit funny. I hope everybody can hear me online as well. We have a visitor today from Germany. She's a collaborator of mine. We've been working together for about 2 years. And Judith comes from the University of Aachen. The university name is a lot longer than this, but I stick to the town's name. And yeah, I'll probably hand over. The topic will be model-driven engineering of assistive systems. Thanks for giving your talk here. Over to you, Judith.
Yeah, thank you very much. Also, thank you very much for the invitation of the possibility of being here. Maybe introduce myself a little bit at the beginning. I did my PhD in Austria. So I'm Austrian, next to the Italian and Slovenian border. Here at the bottom, you can see a picture of my nice hometown next to the lake. I did my PhD about cognitive modeling for ambient assistance in an ambient assisted living project. In 2018, then after my PhD, I moved to RWTH Aachen, where I'm one of the team leaders with 7 PhD candidates in my team. And we are working on several projects. For example, we're part of the Cluster of Excellence Internet of Production, which is a large funded German project with about 100 PhDs working from different chairs of the university. And there I'm one of the 13 coordinators of the work streams. We are working on conceptual foundations of digital shadows, but also working on digital twins. And I'm also involved in our activities in systems engineering, model-driven systems engineering, and several other projects. And I'm quite active in the German Informatics Society. We're a member of the executive board now at the moment. So that's also helping a lot if you're doing your work in research, that you're connected to great other researchers and can work with them together. Therefore, it's really interesting also to be here and connect to you. What I also brought along with me is the research topics of our chair we're working on, so that you can get an idea about what my areas are and what else you can find at the chair. So we have a group working on automotive and cyber physical systems, basically working with all the German, large German car manufacturers. We have several PhDs also working there, where we are considering model-driven engineering, basically related to artificial intelligence for natural language understanding and requirements engineering, but also for picture analysis and several other areas. We have a large group on modeling language engineering, which is basically our foundation, where we have an own language workbench for model-driven engineering. We develop several domain-specific languages for different application domains and work with generator composition, language composition, and these aspects. And then we are having 2 areas, model-driven systems engineering, which is basically a lot doing in production with digital twins and product lines and variability of modeling languages and software architectures. And the other one is assistance and information services. And I'm heading both of these topics basically within the members of my group. So what I'm talking about today is the last area when we're talking about assistive systems and information systems, so how we can model such information. Now, when I'm talking about assistive systems, what is an assistive system? So here you can see a definition. Those systems provide situational support, which means we need to know information about the situation a person is in. This support is based on information which we have previously stored, which is some kind of process information, for example, that you have beforehand, but also structural context and behavior data, which is real-time monitored, which means you need sensors and sensor information. And you provide that support at a certain point in time where the person needs it or asks for it. And if you want to set up such an assistive system, the basic principles are that you have to set up the context information, because you need to have already a certain amount of context information in your system. You have either learned the behavior by observing a person or by using process models where you can know what the important behavior is. Then during runtime, you have to monitor the behavior and the context information to get updates. And then you provide support information. Basically, it's mostly step-by-step support information, which you can then give to the users. And that's highly relevant because assistive systems are providing critical functionality. They're helping in dangerous environments. We all have to care about safety or privacy issues because we're handling very sensitive data in such systems about the users themselves. And they have to be adaptable to specific needs because we have a broad variety of end users for which assistive systems are relevant. So we need to tailor our systems towards their abilities, but also towards their wishes. My knowledge about working on assistive systems basically started when I did my PhD in Klagenfurt. I was working on a human cognitive modeling language. So it had a graphical representation where we checked if it's intuitively understandable for users. Here we were able to capture human behavior as well as context information. We were working on this context information also a little bit more in deep, where we had a look into what are different parts of the context that are relevant and how can we capture that. And we were working on improving the process of this setup of a system, because if you think about how many context information you could have, it's quite a lot if you have to put that into a system. So for example, if you use semantic markup of user manuals or websites, you can already capture a lot of this information into a system as a starting point. And we had some labs, like you see it here in this picture, where we had a test bed with different sensors and the people walking in there and were guided using our system, doing step-by-step certain processes like using a coffee machine or getting ready before they leave their house and such things. So if you're interested in more, there is a YouTube playlist about the project where you can find some of the captures of these processes where people were going through that room. It's quite nice. Now, when I moved to Aachen, I went away from graphical modeling notations and moved into textual modeling notations, which is quite interesting and very helpful if you want to generate a system, because then it's more easier if you have already a textual representation. There we were working since several years now on the generator framework MontyGem. It's basically a framework where we can generate information systems with. So what you do is you give a domain model, which is basically a class diagram in a textual version, together with models for the graphical user interfaces in an own DSL that we have created as input into a generator, which has certain templates for the target code that you generate then. And based on that, we generate the database, we generate the backend of the application in Java and the front end of the application, which is basically Angular, where we create additional TypeScript and HTML files into this runtime environment that we've created here. And the whole process allows us for a very agile process. Yeah, so you can add handwritten code, and we're using the inheritance mechanisms that the programming languages provide us, so that this handwritten code, which you put additionally onto your files, is still available if you go into regeneration processes. And as we've seen in practice, that's something which is happening very often, yeah, so that you're changing your domain models and GUI models iteratively during the process. And then you can still have a running system. Now, if we want to move from such an information system towards an assistive system, we have to think about what areas are additionally needed. So first of all, we also need runtime models because we need process information, we need context information. We could also include goals, for example, human behavior goals into such architectures. And this also means we need additional system architecture components which can handle this runtime models. For example, process engines or model interpreters, reasoning functionalities that we provide the users certain support information. And we also need further visualization techniques so that you have know what is an active process, how to give this step-by-step support, maybe also other devices where you can show the information. So all of these are areas where it's interesting to do some research. Not all of them are researched yet, I can already tell you that. But this is some kind of a big picture where I want to go with my research too. So if we look a little bit deeper into what is needed in the architecture, if you have to make some additions. So basically what we have done is put some additional models into the whole process. So we were already working with models for the model-driven engineering part, with the domain model and the GUI model, as I mentioned. And now we additionally added models at runtime, basically a context model and a task model. And the context model is used to define concrete objects. So you have some domain information in your domain model, but then you need the concrete instances of these objects of real life. And for that, we have this context model. And we have the task model, which is basically the processes we want to support with the assistive system. And those are taken into a data to model transformer component, which allows you to put that information via the storage manager into the storage of your system. And then if a user wants to have support, for example, he asks via the interaction presentation component. The reasoning component is thinking about what is the current status and the current context information that this component has about this person. Then you're identifying what process or process step you want to show to the person, give that to the support component. That information is put together basically into the representation, and other information is added like pictures or audio information, and then given back to the user. So that's the main process, how it works in this architecture. Now, if I'm talking about languages, I'm talking a lot about modeling languages. We are also talking about software language engineering as the technique behind that. So our chair is working massively on how can we improve the development, use, deployment, maintenance of software languages. And these two languages, for example, the context language and the task language, were new and additional ones, but we already had others that were working in that ecosystem, like the class diagram language and the language for the graphical user interfaces. And it's interesting to have a look into how they work together, because in modeling, it's often a problem that you might have separated models, yeah, but you want to use concepts in one model, then also in another model. And therefore the modeling languages and also the tooling behind needs to know about what symbols then are then used in another language, and also the tooling behind needs to be aligned to that. Therefore, we are working with compositional language design. Yeah, so there are several techniques how we can work on that. Basically language inheritance, extension, embedding, aggregation, so the different areas, how you can apply that into modeling languages. And in this large assistive system ecosystem, maybe I can show you it here a little bit. So that's the languages behind that. So when I'm talking about the context language, I'm talking about a language which embeds an own language component, the article component, which is taking, in this case, German articles, because then you can put sentences together. We have terms for giving directions, that you can have relative directions in between objects. We have own units, which you can use in this context language, which are an extension of the SE unit language component, which provides all typical units that you have, like meters and others, but there were several of them not in there for our use case, so we had to add our own units language component for that. And as you see, what we can do is we can take already existing language components and put them together into new languages, and we can connect the new languages that we have also with already existing languages. For example, in this knows relationship, the context language knows about which concepts already exist in the class diagram to be then used during runtime of the system. Now, to make it a little bit more concrete, the use case we have been mainly working on for this assistive system now in the first version is that we provide a cooking support. So basically you have a recipe with certain steps, which you then have to translate into a list of tasks. This is already quite interesting because we thought, yeah, it's easy. You have a recipe, transform these steps into a step-by-step process. But to use such things for human behavior support is not that easy because maybe you have already noticed it when you want to do a certain recipe, there are steps missing. So the recipes themselves are not detailed enough, in fact, to support people. And you also have people with different knowledge skills. Yeah, you have people who know how to cook pasta, yeah, with what degree and when it's ready, and other people where you have to define very detailed what they have to put in and when they have to check and all these things. So all of these aspects are quite interesting and also have to be taken into account. And on the other side of the slide here, you can see a mock-up how this could look like in an assistive system, so that you have 1 or 2 steps in this case. This step-by-step support with additional pictures, textual representation of the instructions. You can have some navigation and some audio guidance where you can read the information which is available. Now, based on this cooking process, we had a look into the domain information. So what is relevant domain information we need to describe this system. We came up with 4 different areas. One of them is the ingredients. So what are the main resources that are used up in a process? So they are gone after you have handled them. We have utensils. So they are basically the helpers in a process, and they are still available then when you completed the process. We have storages, so this is important for finding certain objects where you can hold ingredients or utensils in. And we have machines which have certain functionalities and that you can use then based on what the functionality is they have. Now, first of all, if we want to, so this information is a part of the domain model, which means it is used in the generation process of the system. This also means this information is a part of the data structure that you have in the storage. So then at runtime, you can put real data into this structure and then have your concrete objects you're working with. Now, one aspect which was quite interesting at the beginning is if you want to find something, you need to define where it is and in which relationship it stands to other things. Which means we had to define nested layout information if you have things inside other things and inside other things. So basically storages and machines could have such nested layouts. Here is one of these examples. So if you have a fridge, for example, then we have this reference composite and leaf pattern that we're using here. So you have a reference layout, the fridge, which can be relevant landmarks that you have. Yeah, in a kitchen, you often have a fridge or an oven or such devices as central points. And then based from these points, you can then also define other things in reference to them. In the composite layout, we would then have a door and then different compartments of these door, which are then a part of this composite layout. So based on this information, you can provide very detailed information then to a user where a certain object is if you have defined in which part, for example, compartment 2 also is then the milk. Yeah, then you can tell the user exactly where he or she can find it. Another important information that we need here for this domain model is what functionalities the objects are providing us. Therefore, we have added functional components for utensils and machines. For example, being equipable means that on a stovetop, you can put a certain pot or pan with certain dimensions or a certain height. You can have fillable objects, drainable objects. We had to add that for unlimited, more or less unlimited sources, like water or energy. For the cooking process, you also had steps like cooking or frying. Very interesting was also the machine control part. So you have different possibilities on how to interact with a machine. So you can have a stepwise control, you can have certain modes machines are working on and ranges. And with this additional information, you know what functionalities does a utensil and machine provide. You know, based on your task information, what functionality you need, and then you can match these things in a reasoning component. So here is a concrete example. So for example, we have a machine with a stove and a certain plate. We have some relative position information. For example, the plate is back left. We have functional components. So we have the is equipable, which means 17 in height and 17 in width. And you can cook and fry with such a plate. And we also have a button, which is with the relative position, the third from right. It has a stepwise modification possibility. So it has a range from 0 to 9, and you can control it one step by each. You can also define what it controls. So here we have the relationship between the button and the plate we have defined in line 3. So you can say that it controls exactly that object. Now that we have this context information and we can capture that in our system, let's move on to the task information. As I said, it's a step-by-step information that we have in our task language. So it moves on just from the first step to the other ones. It's just a sequence. It has no nesting parts or so in it. We have defined several types of activities that you can have. So for example, to find ingredients or utensils as a certain type of activity that you can do. You can place something onto something else. You can fill an utensil with an ingredient. For example, fill a pot with certain amount of water and other ingredients. You can operate machines. So for example, to set a plate on a certain degree. And what we also realized is that it's not good to try to squeeze every of the tasks into this predefined kind of tasks that we have here. So we also have these guided actions where you can additionally just add textual information. This textual information is then used for the human user support. And now, if we take all of that together into a generation process, how does it work? So for example, here in the task model, we have the step find fillable with 3 liters and can cook. The reasoning component in our architecture is checking if there is something in our context information which would fit into these restrictions. You can see here in line 8 and 9 in the context model that we have a pot which would fills enough of this part. And we can use then this pot and navigate the user towards the direction. So we have here in S3, which is a certain drawer. So the first drawer from below, which you can see here in the picture. And we can take that to guide the user where he can find this exact pot in this finding task. And the example is in German, so I hope I translated everything as much as possible. So what it says here is that the pot is left from the oven in the drawer cabinet in the first drawer from the bottom. And what you can see here is a certain order in these nested layouts that I've presented you before, which is a reference, composite, and leaf order. And we also made some user studies on what order would be most interesting for the users to get this information shown. So you have it here. The main results from the survey. We had an online survey with 63 participants and asked them also several other questions. So I just took out this question as it fits in here quite nicely. We asked them, gave them several combinations of how we could formulate sentences and how we could help them. And basically it came out that this reference composite leaf sentence structure was mainly of interest for the users themselves. But we also asked them about how we should call a certain number of drawers and such things, or what figures we should use then if we want to highlight certain things in pictures and such aspects. Now, here you can see some other examples, one for operating the stove, for example, where you have the third knob on the right, and you should switch that to level 9. So you have an additional picture which is showing to which degree it should be set, and also a picture which shows where this knob is in relationship to the stove itself, or you have this finding task as you had before. We also have navigation options, so you can navigate to the previous and next task, and you can switch to an overview, and you can also have an audio presentation, so that you can read the text which is shown here. And as I said, none of these texts is in the system as it is right now. So the sentences as they are here are really taken out of the models and put together into fully functional working sentences out of model information that we have in the system. Now, as you already have seen, within these systems, it's not so easy to provide the information that you need to certain user groups, because user groups have different abilities, also different interests, and therefore you need to tailor your system a little bit better to their specific needs. And this is one aspect which is not really covered into the approach that I've shown you before, because we don't really have specific information about specific users, and we don't have the possibility to make adaptations during runtime of the system, just some basic appearance adaptations maybe, which you then have to take for yourself. So therefore, one of the additional ideas for future research we have now is that we also take aspects from the, let's call it problem domain, into our solution space, and take requirements models more into account also in generative processes. So what this means is that we take the real world information that we have and try to understand and model, and we create several kinds of domain and requirements engineering models based on that, such as persona information, but also goal models or additional behavioral information, and make a transformation and mapping into the textual models that you use for creating systems in model-driven software engineering approaches. Because in that way, it would be easier either to have certain user groups where you can then react a little bit more specifically in a system to them, or already generate adaptation possibilities into systems. And when I'm talking about requirements models, as I said, personas is one of the concepts which is quite interesting, because here you can already have certain user groups which you then can use for the generation process, both for already providing some kinds of roles in the system, but also for testing purposes when you test the system for specific abilities, and also in automating this testing. So I think this is something which would be interesting to take into account. We already had a look into goal models, but for goal models, you have them both. There exist goal models in the requirements engineering domain, and there exist goal models more in models at runtime. So for example, for self-adaptive systems, you also have approaches for goal modeling, and they look completely different. Yeah, so they're completely different approaches. They call it goals, but the term means something completely different, in fact. Yeah, in one case for requirements engineering, they're often quite high level and very related to what people are doing. And when you're talking about self-adaptive systems, they are very focusing on what functionalities does the system have and what is a certain system goal, which is behind and not the human person goal. So therefore, it's quite hard to find a mapping here in between. But I think there could be approaches which could help here. So I think this is something also very interesting to have a little bit more look into it. And then also when we're working with feature models, I think this is a very good possibility to have variability in a system and also allow for adaptability then during runtime. Because with feature models, you can already display what different kinds and types of system functionalities or settings you could or should provide. So basically on the personas, that's one of the aspects I want to work in now for the next weeks here in the Humanized Lab. And I'm happy to look for cooperations and discuss the ideas a little bit more together with you. I'm quite fast with my presentation now, I'm seeing that. Yeah, so the basic idea is to contribute to a better world with model-driven engineering and domain-specific languages. I think it works very well for the engineering of assistive systems. So if we take the software language engineering methods into account, think about what languages are needed and could help in such an automated system. I think this is something where we can improve the engineering of such assistive systems a lot, especially as, they are sometimes only appearing for niche areas where you don't really have the large amount of users, like for other systems where you can then let the customers pay for the systems in their large amounts. But I think for assistive systems, you need much more tailored engineering processes and engineering support that you provide here with an increased degree of automation to be able to still provide such systems. As I said, one of the applications that we have now mainly here was the smart kitchen area to support this kitchen processes. But I think it is also well applicable to other domains. So if you think about the production area, for example, there we can have support for manual assembly, because this is also one of these steps where people are still doing a lot by themselves, where they also need to find some items or work with certain resources, but also other domains where I think this could be interesting to apply this to. So in case you have ideas on which domains would be interesting or where you want to collaborate on, I'm happy to hear about that. So basically that's it from my side. Thank you very much. And I'm happy to take your questions.
Thank you for the presentation. Do we have any questions here in the room? Hang on, let me pass on the microphone so our people online can hear you too.
Thank you. Thank you, Judith. Really interesting presentation. I was just wondering, is privacy a concern? Because you have like very detailed information, like where in your fridge, in which compartment you're putting milk. Like that's like very detailed information. So is privacy a concern? Are you considering that?
We have been working also on privacy, not directly related to this project. So first of all, the question is, where do you place the system to? And one of the assumptions that we found out already in our first project in ambient assisted living is that it's quite important that you have your system and the information quite locally, which means if you have such a system, it's better to have your own computer at home where the system is running on and try to send as less information as possible outside of your own home if you want really to use that for your privacy, for your personal support. For other privacy aspects, we've also been working on how to get privacy information into the system architecture, so that you have certain privacy points in your system architecture where you define that you have to check with privacy policies, which the user then can also provide what he or she allows the system to do with this information in these certain points in the architecture, for example. And here we're also working on model-driven software engineering approaches to support that, so that you can both define your own privacy policies, others who want to access the data can define their privacy policies with what they want to use your data for. And then you can have such checking and match processes within the system itself automatically if somebody else wants to access your information. So this is also something we've been working on.
Thank you. I was also wondering, do you consider some kind of artificial intelligence or machine learning to learn humans' behavior? Like you were talking about personas and feature models and those kinds of things. So is any kind of artificial intelligence or machine learning also something you would consider?
Yeah, definitely. I think this is, so I think for the reasoning part there, we already used machine learning approaches to, for example, identify what's the best step that you can provide to a user in a certain time of the day, for example, or on guiding in which process you actually are. But I think there is still more research to be done in that area that you can help here to identify the processes. What we're also working on is using process mining approaches. So where you take the pure data from the persons and then use process, it's not identification, it's process discovery techniques, where you can discover the processes from the real data, and then also make some process conformance checking, for example, if that is relevant for such a system, where you can have firstly the processes as they should be, and then check it with the processes as they really are and how the person is, and then you can use that and match these different areas of behavior. I think this could be interesting, especially if people are changing their behavior or habits in case of medical indications, for example. Because I think this is an area where it's quite interesting. There are warning points in people who are changing their behavior, which could then lead to certain medical indications. And I think this is an area where it could also be helpful and interesting to consider such techniques further.
Thank you.
Do we have any other questions? Okay. Yep, not a problem.
Thank you for the talk. I come from a math background and working on cybersecurity sites. My question is kind of related to privacy as well, but probably more general than that. Do you have also kind of like a team looking at the security side of the things that you develop, or?
Not really, no.
Okay.
So so the generator MontyGem, which I've shown you, we also apply that in several other projects, and in one of those projects we're working together with a cybersecurity group from another university, and they made a security check of the system and also gave us some ideas and hints about what could be improved. But basically, if you reduce it to the basic concerns and the basic functionality that you need and still apply state-of-the-art techniques for security, I think you should be sometimes safe. You're never safe if we're talking about security, or
Yeah.
But I think it would be surely an interesting aspect. So especially if you talk about application domains where it is concerning, for example, autonomous driving assistance or such areas. I think in such use cases, it's then much more interesting to have a look into these aspects as well.
Yeah. Thank you.
Chetan, you next.
Thank you. Very interesting talk. So I was thinking, so in one of your slides, you went from models for information systems and extended them for assistive systems. So I assume a lot of hardware comes into picture, right? The minute you talk about assistive systems and all the non-functional requirements for the hardware. So how do you take that into consideration, going from information systems to assistive systems?
You're right, especially as you have to consider sensors and sensory information. It is also not in this project here. We have another project where we're working on IoT systems. And we have a whole language family defined for deploying information on IoT systems, for example. And if you combine that then with the approach that I've been showing, I think this is something how you can then also handle this additional hardware, because yeah, it's mostly sensors and actuators which are then, I think, relevant here in such systems.
We're back online. Good. Okay, well, thanks for the questions. Do we have any more questions in the room, or more importantly, any questions online? Okay, no questions online. I had a few questions as well, but most of them were actually asked already. And of course, we'll have an opportunity to catch up again and have another chat. Well, in that sense, I would say let's stop here. Thank you very much again for your presentation. Welcome at Monash, and I hope you will have a good time with us.
Thank you.
And thanks everyone online for joining us. See you next time.